Hello, everybody. Today, we are going to be continuing our discussion about the scientific method. Specifically, we are going to be talking about procedures and data. All right. So, before we go any further, why don't you go ahead and pause the video and take Quick Quiz 1.3. Just a reminder, this is your attendance for the day. Quick quizzes are all worth 5 formative points, and you get as many attempts as you want. Remember, your first attempt needs to be on your own without notes so that you can see what you know and what you don't know. I have it highlighted right here where you can find the quick quiz in our folder. All right, we are actually going to be continuing our notes from yesterday, so no need to set up a new notes page unless you'd like to. Our topic will once again be the scientific method, and our essential question will be, how do you apply the scientific method? Our learning target for today, I can explain and apply the steps of the scientific method. All right, so what I would like you to do now is go ahead and pause the video that you are watching here and head over to Nearpod. And I want you to just go ahead and watch this video that I have here. This is from last week during our synchronous meeting when I made peanut butter and jelly. And you all gave me some instructions. So I've gone ahead and include that. So go ahead, just pause this, go back and watch it, and just remember the great time that we had. All right. So why did we do that? What was the whole point of me making peanut butter and jelly based off of your instructions? Well, we were talking about procedures there, and we're going to be writing procedures in this class. And so if you want to, you can go ahead and turn to the procedures examples handout in your packet. And today we're going to talk about what a good procedure and what a bad procedure looks like. And when we make a procedure, we want something that we could give this procedure to somebody else and they would run the exact same experiment that we ran. So we kind of saw that with the peanut butter and jelly, that the more specific you were with your instructions, the better off, the more likely I was to make the peanut butter and jelly sandwich as you thought I would make it. So let's start off with what a bad procedure looks like. So for both of these procedures, we're looking at a purpose question, or a purpose of, does temperature affect the rate of lightning bug flashes? So this would be an example of a procedure you would not want to write. Get a jar and some lightning bugs. Put the bugs in the jar. Count how many times the bugs flash in 5 minutes. Make the bugs hot by putting them near a heater. Count how many times they flash during the next 5 minutes. Record your results. So right off the bat, we have a ton of issues in here. How many bugs are we using? What size of jar are we talking about? What's the original temperature of the jar? How much are we increasing the temperature? So there's a lot of different things that aren't really laid out here. If I gave this procedure to every single one of you, every single one of you would run a different experiment. And so this is not what we're looking for when we write a procedure. So let's look at a good example of this same purpose experiment. Once again, does the temperature affect the rate of lightning bug flashes? Right off the bat, just check out how we have listed numbered steps. It just makes it so much easier to follow. Step 1, place 1 bug in the jar. 2, put the jar in a dark room that is 62 degrees Fahrenheit. 3, record how many times the bug flashes in 5 minutes. 4, raise the temperature in the room to 72 degrees Fahrenheit. 5, record the number of bug flashes in 5 minutes. 6, raise the room temperature to 82 degrees Fahrenheit. 7, record the number of bug flashes in 5 minutes. 8, repeat steps 1 through 7 with 9 other bugs. So, if I gave this experimental procedure to every single one of you, I'm pretty confident that everyone here would run the same experiment. So a couple of things to notice in here. Once again, I said the numbered steps are really good. We give specific numbers when it comes to the temperature in the room, which is important. The other thing is we run trials. So we did our original temperature, we raised it 10 degrees, we raised it another 10 degrees. So we have those 3 different measurements we're taking, and then we do 9 or 10 total trials. So that gives us a bunch of data that we can look at and compare, and that just gives more robust results. So, and also notice, because this also came up sometimes in the PB&J, that I said repeat steps 1 through 7. So you don't rewrite 1 through 7 9 times. Just say repeat whenever you can. That's an excellent use in order to kind of save yourself some writing. All right, so in your lab, which you should have completed the first few parts of that, we are going to be working on the procedures today, and I want you to make sure you are using the previous handout to guide you as you write your procedure. So so I've got here the listed steps, so that's going to be helpful. In addition, I've got some extra information here on the lab that kind of helps you. If you need more than 6 steps, put your cursor in that last box there and press the tab button. That will add another box to this list, which is excellent. All right, so one of the big things that I want you to remember when you're writing your procedure, do not get bogged down in the folding steps, because if you try to say fold this at a 45-degree angle and then fold this corner at a 30-degree angle, it's going to get really difficult really fast. Instead, I got a couple of ideas for you. You could try something like fold the paper airplane according to instructions on this website, fold the paper airplane according to instructions on this video, or draw a diagram on how to fold the airplane and include it. So that's just a kind of a little bit of help for you there. All right. What is a question that the previous slides answer? Go ahead and pause the video and fill out your guiding question for the procedure. All right, let's talk data. We have 2 types of data that we are interested in. We have quantitative and qualitative data. Quantitative data is information from an experiment that can be recorded using numbers. So I usually remember quantitative data is number-based because the word quantity is basically in there. You can see it right there. And quantity is the number of something that you have. So quantitative is number-based. Also, quantitative has an N in it, N for number. So in our experiment, so let's think the lightning bug experiment. Some examples of quantitative data include the temperature. We measured the temperature using numbers. We had the bugs flash for 5 minutes. We counted the number of flashes. We had 1 bug in our jar at a time. We repeated with 9 different bugs. All of these are examples of quantitative data. In your paper airplane lab, quantitative data might include distance, it might include time, it might include speed, it might include height, it might include a lot of different things, but anything that you are measuring involving numbers, that is quantitative data. Qualitative data, on the other hand, is information from an experiment that can be recorded using descriptions from the 5 senses, that is sight, smell, taste, sound, and touch. Basically, any sort of information you gain from the experiment that is not numerically based. So, for example, qualitative data and quantitative data actually are pretty closely related to each other. Because, for example, I could say, I feel hot, or this jar feels hot. That's qualitative data. But if I take a thermometer and I measure that the jar is at 100 degrees Fahrenheit, that's quantitative data. The qualitative data is that it feels hot. Quantitative data is when I give a number associated with it. What is a question that the previous slide answers? Pause the video. Alrighty. All right, folks, that's it for notes. Let's go ahead and take a quiz. Just pause this video, take the quiz, and then come back and I will explain the answers. All right, so an example of quantitative data. Well, we look at all these very interesting facts about Mr. Roser, and the only one that has numbers is Mr. Roser is 172 centimeters tall. Mr. Roser's dog, Mosaic, is a Shepherd Husky mix. This is an example of, well, that is something that you can see about Mosaic, and so sight is going to be something that is qualitative. We actually did do a test about that, and we did find out that that is her genes. So let's go ahead and check it out. Hey, perfect score. How exciting is that? Alrighty, folks. If you have any questions about writing your procedure or data, go ahead and post it in today's Schoology discussion. I'll jump over there at some point and make sure that your question gets answered. All right, go ahead on a scale of 1 to 5. Let me know, how well do you understand the scientific method, variables, and data? All right, folks. So the rest of the time today, what I would like you to do is focus on working on your paper airplane lab. So here's what you need to do. You need to write the procedure for your paper airplane lab and identify the data you will be collecting. What is it that you're going to be measuring about your different paper airplanes? And how are you going to organize it? Right over here on your lab, I've given you a little table that you can use. I would say the vast majority of you are probably going to use this type of table to record your data. That being said, if you have something else, cool, go for it and see what happens. But that's what I would recommend. Use the procedure examples to help you write a good procedure. Please remember that you need to check in with me at least once this week through Google Meets. So in the folder today, there is a link to schedule a time to check in with me. I want to see how your experiment is going, if you need any help, and also just to get to know all of you. So please make sure that you check in with me at least once this week if you have not done so yet. Once you've written your procedure and know the data you will collect, go ahead and run your experiment. We remember you are going to need to have this all finished, and we are going to talk about writing a conclusion tomorrow. And so this entire lab is going to need to be done by Friday. So please make sure that you are budgeting your time appropriately and that you are getting done. If you need any help whatsoever, please feel free to reach out to me. I would be very happy to help you.